All right, what's up? Let's talk turning points. Let's knock it out pretty quickly. One thing that is worth writing, I'm just going to throw this up on the top of my paper here. If we've got even, or hold up, it was the opposite way for the notes, right? We had even, we had odd, and then we had positive, negative, right? An even positive is an upwards U. We've got a downwards U for an even negative. We've got our odd positive going up and our odd negative going down, right? This is good with your money. This is bad with your money because it's going from high to low. So that's how we remember it. Keeping that in mind, turning points. The points at which a polynomial function switches direction. In other words, I don't really like the way that sounds. It's going up and then it's going down. That means we have a turning point right here. Okay, now, if the turning point is higher than any point nearby, it's called a relative maximum. And these are like the mountains of the graph. These are the hills of the graph. That is not very complicated. If the turning point is lower, it is called the relative minimum. I'm sure you guys, I'd have bet $100 you guys could have come up with that one on your own after hearing the first one. Maximum and minimum values are called, they can be called extrema, as in these are the extreme points in the graph. Let me write this a little bit better because it doesn't really sound like a word, right? Extrema. These are the extreme points of the graph. These are the extreme heights and the extreme lows. And turning points is where we define where the function is increasing, decreasing. So here is the big kind of revelation that we're making here. Here's the whole point that we're doing these notes. If I've got my extrema, or my relative maximum here, my relative minimum here, the understanding that it is at these points where I have swapped from going up, 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 get to the top of the mountain, time to go down. Oh, that doesn't look very red. Down, 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 get to the bottom of the valley. Now it's time to go up, 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 up. That these maximums and minimums are the split between the two. And so if you want to know when am I changing from increasing to decreasing, if you look for the top of the mountain, you'll find that the change super easy, okay? What we're going to do is do this using a calculator, but here's the good news, okay? Let's do all this. Let's do this. Let's make this extra big. Let's get a nice color. Let's get a nice green color. Here's what we're up to here. Oh, this looks terrible. Desmos. Desmos. We don't need to do any of this that they're saying. We're doing Desmos. Okay, we don't need to use the graphing calculator. We don't need to do all of this complicated. Oh, I think it just reset. A little bit weird. We don't need to do all of this complicated, go to your y equals graph, then use the calc, then hit enter, enter twice, find your, just type it in Desmos. Okay, we know that if we type it in Desmos, it's going to give us those gray dots. It's going to tell us where our max is, and we're done from there. So we're going to Desmos. We're using number 1. Let's see how this graph looks. Okay, going to Desmos. I need to type in negative x cubed plus 3x squared. Negative x cubed. Whoa. Negative x cubed plus 3x squared. Double check you've typed it in right. Negative x cubed plus 3x squared. Negative x cubed plus 3x squared. And then check it here. Negative x cubed plus 3x squared. There you go. I typed it in wrong. That's why you triple check it. Go ahead and go back home with the home button. And you can see we've got a cubic negative function. We've got an odd negative function. It looks bad for your money. Going high, crashing down. And so how does this function look on the graph? Well, we click on the purple graph. We click on the purple dots. All of these purple dots are interesting to us in some way, okay? And luckily, these are very easy to graph as well, okay? So let's put all these on our graph, 0, 0, 3, 0, and 2, 4. So on our graph, I think I need to make this a bit smaller. Zero, 0, 3, 0, 2, 4. Those are my 3 gray dots that I got from Desmos. Now I need to connect these and kind of draw the picture. So it goes down, then it went up, and then it went down. The drawing doesn't need to be great, but it needs to have those perfect gray dots, right? Those gray dots are very specific. And so you can't just pick any particular point for your peaks or your valleys. Now looking at our graph here, and you can tell it, mine is a mess. But looking at our graph here, we also need to identify what are these kind of gray dots. What are these 3 important points that Desmos has told us, okay? So for example, let me make this look a little bit nicer, right? Coming up, going down. Okay, graph looks a little bit better now. What I've got here is this first one is an x-intercept. The second one is also an x-intercept. This first one is a y-intercept as well, because I've touched the y-axis. And here's the stuff we really care about. Okay, this right here is a minimum. And this right here is a maximum. And so all of these things, I mean, we should be able to identify these pretty easy, right? We're touching the x-axis, it's an x-intercept. We're touching the y-axis, it's a y-intercept. We are a maximum at the top, we are a minimum at the bottom. And some students, I mean, I don't expect you guys, because you guys have been so smart this year, but this is not the top of a mountain. This is not the bottom of a valley. This cannot be considered a minimum, because it's going to keep going. It's not the smallest point in the area. And so now we need to kind of fill out some of our information on the graph. We've got a nice function. This function is going right, left, domain, all real numbers. This function is going up. This function is going down. The range, all real numbers. That shouldn't be super tough. We've got no asymptotes. We've got no like holes. We got nothing weird going on. We like polynomials because they're pretty easy on us there. Our maximums and minimums. So we kind of already labeled these. Our maximum was here at 2, 4. Right? This is our maximum right here. Our minimum was at 0, 0. Again, just going back to Desmos. Yeah, minimum 0, 0, maximum 2, 4. 3, 0 is just an x-intercept, not a maximum or a minimum. Our in behavior, we should already know how to do this. Our in behavior on the positive side is negative infinity. On the negative side is positive infinity. We know that odd negatives are going to have the backwards behaviors, right? So positive means negative, negative means positive. And now we're getting to increasing, decreasing intervals. And if you remember, increasing, decreasing intervals were a little tricky when we did them earlier. And now they're going to be, honestly, even trickier because we might have more than just one increasing, one decreasing, okay? If I trace this function, I'm going to start down, 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 right? This whole time here, my function is going down from left to right. This is a very down function. And then in this middle portion, I'm going up. And then again, in this final portion, I'm going down. So what we're looking at here, besides my terrible handwriting, is that we have 2 decreasing intervals and 1 increasing interval, right? Down first, take a little break to go up, and then down again. That means we can expect our intervals, and you don't have to do this, but our intervals are going to look something like this, right? Decreasing for 2 different intervals, increasing for only 1. We know it's going to look like this. One of these is the first down, and then the up, and then the second down. And a really quick reminder about how we did the increasing, decreasing before, okay? Let's say that we had a function, and it looked like this, and at this point right here was at 2, 0, okay? We would say that we were decreasing first, increasing second. We would say increasing, decreasing. We would start with our increasing, we would start with our decreasing because we're decreasing first. And we would say that we are decreasing always starting at negative infinity and always using x values of 2. Once we found the very first one, the rest of them were easy because we would use this same number again to the positive infinity. Because this point is the exact point that we've swapped. And so we need it as the end of our decreasing and the start of our increasing. Remember, all parentheses, because we're not including that value 2. And also that we're always going to go from negative infinity to positive infinity, because we're always reading from left to right using the x values. Okay, all those being said, look at my function here. You almost want to think of it like this, and maybe this is going to look ridiculous. This whole region here is the region where my graph is going down, right? Here it is, down, 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 down. I'm going down this whole time. But then this middle region right here, my function is going up. And then again, my function is going, try not to ruin my nice green that I've got there. This whole region here, my function is going down forever. And so if you kind of think about it like this, a lot of times that helps you recognize decreasing, increasing, decreasing. Those are my 3 intervals. This one, the middle one, and this end one, okay? We need those x values. Let me get all this junk off my graph now. We need those x values. And so we're going to want these x values, the 2 and the 0, straight from our maximums and minimums, and we're going to do our increasing, decreasing, okay? It's really not as hard as it looks. We're always going to start, we're starting decreasing, so we're always going to put a negative infinity first because we're always starting at negative infinity. Even though it looks like it's very high up at positive infinity, we're talking x values, it always, always, always negative infinity. And then you just take these numbers right here and you pick the lowest one. The lowest number would be a 0, so you put a 0 here. And that is our first decreasing interval, right? That's from negative infinity all the way to 0. And now, time to do increasing. We're going to use the same number again. And then if we're done, if we're all out of other maximums and minimums, we'll end it with infinity. If we have more maximums and minimums, we'll just throw that other number in there. So we're not done yet. We have this value of 2. So 2 will go there. We're always going to use it twice, so we'll use 2 again. And then we always end with a positive infinity. And that is how we do increasing, decreasing, okay? Maybe I've overcomplicated it. I think on the second way through, it'll seem really, really easy. But we're taking these values that are right in between. We're just going negative infinity, the first one the second one to infinity. And we're done. So I'm going to knock this one out really quick. We're only doing one more question, then we're done with the notes. Number 4, I have no idea how this looks. I do know that it is a positive even function. So if I wanted, I could already do this. Infinity, infinity. right? Positive even means up, up. The rest of it, though, let's just see how it looks, okay? I want to be extra careful typing this in. X to the fourth plus x cubed minus 4x squared plus 5. X to the fourth plus x cubed minus 4x squared. Let's make sure. X to the fourth, x to the cube, minus 4x squared plus 5. All right, here's my function. Now, this function is a W. It's up, up, just like we thought. But we've also got, if I click on this, a bunch of grade points. 1, 2, 3, 4, 5. I really only need the maximums and the minimums, okay? So I see a maximum at the top of that valley. I see 2 minimums here and there. Now, these are decimals, and when we go to place our points, we need to write these exactly on the list, but on the graph, obviously, I don't expect you to graph these perfectly. So on our list, our maximum needs to be 0, 5. Because again, 0, 5 is the maximum, but our minimum is going to need to be these long decimals. 1.088, 1.088, comma, and 2954, 2.954, and we need another point, this one down here, negative 1.838, negative 1.838, comma, and then negative 3.31. Negative 3.31. Make sure this is a parentheses, not a bracket. Okay. So we've got our maximums, we've got our minimums. Let's go ahead and graph those so that we can throw up our graph, how it looks. We've got a function as 0.05 right here. 1, 3, just about. -2, -3, just about. Look, it doesn't have to be perfect. As long as we've got these labeled perfectly, obviously you can't be expected to graph these like a robot. We know that we're an upwards facing W, so we should look like 1, 2, 3, 4, something like that. And we're almost done. Domain and range, okay? Does our function go to the right? Yes. Does our function go to the left? Yes. Our function goes everywhere. Domain, all real numbers. Range, does our function go up? Yes. Does our function go down? Not quite, right? We have a barrier here for our range. That is as low down as our graph goes. Now, to be very clear, there's no asymptote here. But this is the lowest that our graph gets, is right here. So our range cannot be all real numbers. Our range needs to be that lowest value of y, which would be this number right here. That would be negative 3.31. And then our highest value would be infinity. You could also write it like this if you wanted. Oh, I need a negative there. That looks terrible. Y is greater than negative 3.31. Now, this is the big idea. This is what we've been working for. Increasing, decreasing intervals. Again, you're thinking about these as the places that you have traded out, that you have swapped from decreasing to increasing. We're looking at these x values, 0, 1.088, and negative 1.838. Those are the x values of our maximums and minimums. Those are what we're going to use down here as our increasing, decreasing. And something that I like, especially when you're starting out, is to do this process of down, up, down, up. So I should have 2 downs, I should have 2 ups. And so I will start by writing my intervals, 2 ups, 2 downs. And I think that this really helps steer you on the right path. And it's a really easy way to get confident that your answers are looking good. So now, which one are we doing first? We're going down first. So we're always going to start with a negative infinity. And now we're just going to start double tapping on our x values from lowest to highest. So what I mean by that is we're going to pick our lowest of these 3, which is this negative 1, negative 1.838. We're going to use it once, and then we're going to double tap. We're going to use it again, negative 1.838. Now we're going to keep going. We're going to go to the next lowest value, which would be 0. So we're going to use 0. And then we need to make sure that we're going to the right place, right? Because we're going decreasing and then increasing and then back to decreasing. So that 0 needs to be on the bottom here. We're kind of going to zigzag as we go through these because we're going down, up, down, up. So we're going up, down, yeah. Then we're going to the next one, which is 1.088. Same one again, 1.088. And now we're all out of these x values. Finish it with a positive infinity, and we're done. Okay? So it's really, 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 the thing that you're trying to get today is the understanding that these maximums and minimums are the places that you trade off. These x values are the only values that you need. And then the repeating of these x values is what I found really, really helps students kind of feel confident that they've got the answer right. So that is the notes on turning points and how to use your maximums and minimums and your extrema on how to go up and down. That's pretty much it. Nice job.